In this lesson, we're going to graph inverses of functions. And we've talked about inverses in the past where we found the inverses algebraically. But today we're going to add a graphical part to this. So we're going to start off with the notation. And basically, the inverse of f of x is going to be denoted by a little -1 symbol. So the inverse of f of x is denoted by this, f -1 of x. That does not mean you're taking the reciprocal of f of x. That's just notation, and the -1 implies that this is the inverse of the original function x, f of x. Now, as I've said previously, we found the algebraic inverse, or we found the inverse algebraically. To do that, you switch x and y, and then you solve for y. So we did that in the first unit, I believe. And what you had to remember is if you are finding the inverse of an even root, when you solve for y, you have to use the plus and minus. So I'm going to walk you through some steps to graph the inverse function. And that first step is going to be to graph the original function itself. So you're going to graph f of x, and then you're going to pick at least 3 coordinates from f of x, and we're going to apply the rule to those 3 coordinates. So you want to make sure you graph f of x accurately, and then pull at least 3 coordinates. Make sure they're fairly spaced apart, because I know if I think of the cubic function, there are 3 coordinates that are very close together that are gonna look linear, and that's not going to help you. So choose at least 3, sometimes more than that, and then from those coordinates you're going to switch x and y. So you're going to apply the rule for the inverse. Oops, that's what I get when I talk and write at the same time. You're going to switch x and y because when you graph the inverse function, you are really reflecting the function over the line y equals x. So the inverse of that function is what you get when you get that reflection. And the rule for reflecting over the line y equals x is switching the x and y values. So when you think of your symmetry rules, x, y will map to y, x. So that's why we switch x and y, and then we graph the new coordinates. So once you graph the new coordinates, there you should have enough to sketch your new graph. And again, it's going to be a reflection across the line y equals x. And then if you have a function that had a restricted domain or range, if the domain or range is restricted for f of x, then the rules are going to switch for the inverse. So if the domain is restricted for f of x, the range is going to be restricted for the inverse. And the asymptotes are also going to switch. If we have a horizontal asymptote for our original function, then we're going to have a vertical asymptote for our inverse. Alright, so here's an example of what we're going to do. I'm given an original function, f of x is equal to x cubed plus 2, and I want to graph its inverse. So I'm going to start off by graphing the original function. This is a cubic, and I know from my transformations that this is a translation of up to what's called a vertical translation up 2 units from the origin. So if I graph my original, instead of starting at the origin, I'm starting up 2 units, right 1, up 1, left 1, down 1. Those 3 points are too close together to use by themselves to graph the inverse. I'm just telling you right now. So from here, if I go over 2, I go up 8, which puts me up to the top here. My dots aren't very good because it's hard to do this on the iPad. If I go to the left 2, I go down 8, which puts me down at -6. So here's what my original cubic function looks like. That's f. And now we want to graph its inverse. To do that, if I have f of x, I'm going to choose some coordinates. I have -2, -6. Let's do -1, 1, 0, 2, 1, 3, and 2, 10. I chose 5 points, again, because the 3 are just way too close together. And what tends to happen is if you just graph these 3, you start graphing a rotation instead of a reflection. So here's my new graph, f -1 of x. I'm going to switch x and y, so this is going to map to -6, -2, 1, -1, 2, 0, 3, 1, and 10, 2. So I'm going to put those values on the graph. -6, if I can do it here, 1, 2, -6, -2 is here. 1, -1 is here, and this helps you better to see what this graph looks like. 2, 0, so here's the 3 points in a row that look linear if you don't graph other points, and then 10, 2. So here he is. There is my inverse, and it'll look much better when you can use pencil and paper instead of me on this iPad because it looks a little sloppy. But if you were to sketch the line y equals x, it should look like a reflection through that line. And there are no restrictions on the domain or range, so it just stays like that. So the second half of the union